Welcome to the special topic, which is there a strong link between extreme storm events and climate change? And before we get into this too far, I just want to say that every time that there is a major storm event that occurs, one of the first things that always gets questioned is whether whatever the major storm event is, whether it be drought or flooding or hurricane, is that the cause of global warming? And the truth is that global climate change is a very nuanced thing with a lot of characteristics. And while we understand the mechanisms of how it is occurring and why it is occurring, we know what's the cause. We don't know how that's always translating, and that's because the energy system, that net energy system of the Earth, going all the way back to our earliest modules in this class, Module 1 and Module 2, when we talked about net radiation and what's that coming and going energy balance and budget. That is such a nuanced and specific thing based on so many things. Surface of the Earth material. What is the Earth's surface? Is it continental or marine? What are the wind conditions? Where is it located? Is it near a high pressure system, low pressure system? How is that energy changing form? Is it in light? Is it in heat? Is it in motion? So is it wind, right? What is it doing? Is it changing its phases? Is it water going from gases to solids or liquids? All of that matters and all of that plays into it. So a lot of the information that's put out there isn't after the fact. It's after we've collected the data and crunched the numbers that we can say definitively that it's derived or caused by or strengthened because of global warming. So there would have been a hurricane, but had there not been more energy in the atmosphere, it would not have been a category 5. It would have been a category 3. And so these questions are always very nuanced and difficult to determine and difficult to argue. Yes, why? And they're very specific. And so you have to really look at scientific data. And so before I continue into this too much, I'm going to show you data. We're going to talk data. And I'm going to say not everything is definitely one thing or the other, and it can allow you to question a system. So one of the first effects that we're going to see within weather patterns is rising temperatures, which can affect weather conditions, because with rising temperature means that the air molecules are moving farther and faster, which means that there's more space. Where there's more space, I have greater air capacity, which can allow more space for water to be within the atmosphere itself, which means the moisture that's accumulating can create a bigger cloud, right? A bigger cloud means that there's more water. More water means stronger rain, for example. That rain, if it can't permeate through the soil, means potential for flooding. So that is one of the ways I can create a connection through global climate change, but you could see how complicated that system of steps was to get from point A to point B. So one, it can increase the rate of evapotranspiration, which is that act of moisture in the atmosphere. Another major thing is that a warm atmosphere can hold more water vapor. If it holds more water vapor, it can actually increase the inability to rain it out. And so when it does, it's collecting even more rain before it reaches its saturation mixing ratio. So going back to Module 5 when we talked about that, right? So everything repeats. It takes more to get to that point before it's going to actually drop that moisture. So instead of having kind of small rain events that pepper the earth and keep everything moist, we're going to have extreme rain events where it's going to be dry for a while and then it's going to rain out huge amounts of rain, which means the soil surface can dry out, not a lot of permeability of that water, more likely flooding conditions. And so certain things we're going to see perpetuate based on these differences. The start is warming effects on water. These are temperature anomaly distributions based on various years. And you can see that these sort of what we consider normal, the zero temperature on our line is right here. So this is our norm. And we can see that in recent years, going all the way up to the 2001 through 2011, the temperatures yearly on average over the surface of the entire Earth are skewing to slightly warmer, and about 1 to 2 degrees warmer on its set in its temperature anomalies. Rising temperature can affect several things. One of them is change in sea surface temperature. And while this doesn't automatically generate a storm, it does create, because we already talked about the steps to a storm, right? It's not the definitive reason. It does create the proper conditions for a storm. So it helps create the conditions. And so here's ocean surface temperatures. And you can see that ocean surface temperatures in the last few years have actually increased to be a little bit warmer and a little bit higher as we're moving through periods of time. And so things are getting hotter. That's basically the key. This is 2011 on its set. And of course, we've talked about ocean surface temperature is the warmest it's ever been in the last 10 years since we've been taking surface temperature data. And surface temperature data relates back to the 1800s because we used to take it way back then when we were just doing early nautical conditioning, right? As far as long-term climate trends, there's some long-term trends that we have all agreed upon. And so just going into this and what we expect, scientists in 2012 said that it was the ninth warmest of any year since 1880, and that they're continuing this. The hottest years on record, some of them have occurred within the last 10 years, and this is continuing to be true. And observing changes in weather events is also very important, and depending on region, we can expect different changes in our weather events. So, for example, if I'm looking at change based on reporting, I find that there is decades-long studies on rainfall, and heavy rainfall events themselves have increased in intensity by about 20% in the last 10 to 15 years. The intensity of rainfall has increased most specifically in the regions of the Northeast and Midwest. As far as who's getting wetter, so who's getting heavier rainfall and a greater amount of moisture, this is what we see. So these are heavy rainfall events have increased by 13% way up in Alaska, about 12%, 16, 13, 27, 18. And then up here in the New England corridor, which includes us, we have seen an increase in heavy rainfall events by 58%. So every time that you guys drive the sawmill and you're like, man, it rained again and the sawmill's flooded, we really should take care of this. Yes, we should, because the heavy rainfall events that are flooding a lot of our roadways in Westchester are just going to continue to occur. So we need to start to figure out those drainage systems here because that's not changing. This is our new normal. As far as U.S. global changes, research programs that have published reports in 2009 entitled Global Climate Change Impacts in the U.S. National Climate Change Chapter reported the following findings in recent decades. Frequency in drought has increased in areas such as the Southeast and the West, and there is a decrease in other areas. Rising temperature make drought more severe and or widespread, and they also lead to earlier melting of snow impact. And that's actually something that we just recently keep hearing about every year, every winter. We keep hearing about the snowpack in the Sierra Nevada mountains not being as much as it used to be 10 years ago, and what concern that is for their water supply, their groundwater supply, because those snowpack ice, which then melts into their groundwater for the summer months, is not what it used to be in collection of snow. Now, this is ice thinning over the Arctic, and you can actually see the ice thinning pack and where we see the terminus increasing. And that's something that you just keep hearing about, was how much the glaciers are melting. And the key is the glaciers are melting. And then just going a little bit into drought impacts, there's been an increase in drought in certain regions of the United States. And the places where I've seen a decrease in drought are in blue. And just notice that these are these wet areas where we've seen an increase of heavy rainfall, right? So these are the regions of heavy rainfall in that other map. And then the regions where we've seen a heavy rainfall, but not in high percentages that are only about an increase of 10 or 12%. So the soil is impermeable, has seen increases in drought in the United States. Going into this climate research again, we can now talk about Atlantic hurricanes. And there's two pieces of data that we found